That's the sound of solar-powered air conditioning running inside of a Chevy Express van with absolutely no outside indications that it is a camper van with an air conditioner or refrigerator. It's even got a little sink in there. But from the outside, it looks pretty much factory. I'm gonna go ahead and climb this ladder so I can show you the 750 watts of solar panels that I added this weekend using VHB tape. So I did not have to add any holes to the vehicle. And furthermore, I was able to run them in this existing air vent, so I didn't have to put a hole for the wires either. So there's the refrigerator and the portable air conditioner that we have in here. And I'm gonna pop myself inside and explain what we're looking at here. So the solar wire runs there, and then it runs along the roof next to the American flag and down into this XT60 connector right here. And the reason we have an XT60 connector there is so that we can disconnect this and then plug it into the EcoFlow Delta if we wanted to use the solar to recharge that. But additionally, this connects in through this breaker here and then plugs into this MPPT solar controller. With 750 watts of panels on the roof, we're getting about half that much in wattage, which is pretty typical. So 375 is not bad, and from this solar controller here, we actually have the load connected to another solar controller here. So this one goes up, and we have the wire shoot around, and it connects into the solar input of this here. And so this right here functions as a DC step down so that we can use our 30 volt batteries with the 12 volt system. So let me get to that next. This is the typical battery that you would put in a vehicle like this if you were going to go with a lithium iron phosphate battery. This is by and far much smaller than lead acid batteries, especially when you're pulling 750 watts. Or, to be more precisely, 733 watts. You would need around 800 amp hours of lead acid to equal roughly 400 watt hours of lithium iron phosphate batteries. But still, even with those batteries, we didn't have space inside this vehicle because typically on top of this wooden platform is a bed, and there really isn't any extra space in here to add more batteries. So what I was able to do is I grabbed, using this different type of battery pack. This is nearly identical to what you're going to see on an electric bike, and these two batteries here versus this battery here have the exact same energy capacity, but as you can see here, the white batteries are half of the volume, so that means I'm able to get twice as much space, and because they're so skinny, I'm able to actually kind of stack them like Tetris. So I'm gonna go show you over here in this previously entirely unusable wheel well space that I was able to get all of the batteries in there. And each of these batteries is paralleled together and connected with a fuse, and then 5 parallel packs are put together and connected with a 50 amp breaker. So there is an independent battery management system on each individual pack, and then a 40 amp breaker, and then a 50 amp fuse. So this is a very safe system with these batteries right here, and it uses the exact same battery technology that's in that EcoFlow Delta, which has been inside this van for, I believe, a year without any problems at all. So there should not be any problems with these batteries. But if you were to be in an extreme environment where you're going to get well into freezing, or where the interior temperature would hit over 140 degrees, then this would not be the battery choice for you. You would want to stick with the lithium iron phosphate batteries, which have a slightly higher maximum temperature and a lower minimum temperature than these batteries here. But the primary reason for this was energy density. That is huge, and that's why 90% of the devices that use batteries use this type of battery technology. So with this right here, we have a lot of nice flexibility. We actually also can disconnect this, and I can plug in an AC rapid charger, and we can send 1200 watts into this system here, which is going to go into those lithium batteries there, and it'll recharge those at 1200 watts in around 4 hours to about 90% full. And then if I want to completely top it off, it takes an extra about 90 minutes to get that full charge on this system. But right now we are doing a discharge test on this AC, and I do believe that we're going to get somewhere between 7 and 9 hours running on this, because this is a very, very big battery. And so far I've been exceptionally happy with the system and its performance. Everything runs very cool and quiet, and it is also fully programmable. So if you wanted, for example, lights to turn on at 7 o'clock and turn off at 11, or if you wanted, to be able to turn something on and off with just your phone by connecting to this with Wi-Fi or Bluetooth, that's something that you can do. Additionally, if you wanted the air conditioner to automatically turn on when it reached a certain temperature because you have a pet inside the vehicle, you could do that as well. Or you could have it automatically do something like turn the refrigerator off when the power is low. Anything that you can think to automate this system so that it makes it work better for you is something that you can do, and that's built into this system right here. So it is designed for full automation. But currently it's pretty much just a real basic system. Turn it on when you want it and turn it off when you don't. And everything has safety features so that it's pretty much impossible to break this. And this is a bit unorthodox, so I hope people looking at this learn something and try to clone this system, because I was very happy that I got the opportunity to do this, because I've never seen a system that can run an air conditioner inside an incognito van like this before. So I'm just very happy with the results, and I can't wait to get some feedback on real-world testing and living in this. So I'm very happy.